In this video, I'll be showing you how to find some logarithm that are not that easy to do mentally, because I know if I gave you logarithm of to base 2 of 8, that's pretty easy because I'm only basically asking you what power you're going to use with 2 to get 8. So obviously you use the 2 with 3 to get 8, so the answer to this will be 3. Okay, and so many other ones that are very easy, like log base 5 of 125. The answer is also 3 because 5 to the third power is also 125. So there are these ones that you can do mentally, like this. But there are other ones like this one I have right here, log base 27 of 3. That it might not come that easy. So I'll show you a general method of doing this so that you don't have to mentally carry the weight. So let's get down to it on solving this kind of finding the answer to this kind of logarithm. So if I ask you what is the logarithm to base 27 of 3, so basically I'm asking you what power I'm going to use with 27 to get 3. So notice I have used x to represent the what power. We don't know the power, so that's our unknown, what power x. So the advantage of writing in this way is because we can actually try to get each side of this equation to have the same base. If you're able to get them to have the same base, then you're on your way to getting what is x. So I have 27 here, I have a 3 on the other side. So to get 27 to have the same base, I can simply write 27 as 3 to the power of 3. And then that's x right there, so it's the same. So as 3 to the power of 1. Now, so if I apply the power property, I just multiply the 3 and the x, so it will be 3 to the power of 3x equals 3 to the power of 1. Okay, there is an equality property that applies to exponential equations like this. So if I have x to the power of a is the same thing as x to the power of b, then obviously if the base is the same, the exponent has to be the exponents have to be the same. So a has to be equal to b. So we're going to apply this property to this situation here. So if the base is the same, see, look, the base 3 is the same as 3, then the exponent 3x must be equal to 1. And that's exactly what we're going to do. We're going to set 3x to be equal to 1 and then divide both sides by 3, so it will be x equals 1/3. So now we solve the problem that if you use, so our answer is x is equals to equals 1/3. That means that if I use 27 with the power of 1/3, I will get 3, which makes sense because basically we are taking the cube root of 27, which is 3. So it checks out all right. So writing it this way allows us to set up an equation to solve. Okay, here is another example that may not come easily, but might be a little bit challenging. So let's say you are asked to find the log of, so this is a log, example 2, the log to base 27. No, let's use another one. So we've used that one, base 16 of 1/2. So let's say I'm looking for the log to base 16 of 1/2. So I will start off with the same way. I will do 16 to what power equals 1/2. All right, 16 to what power equals 1/2. And then now I can go ahead and write 16 to a base that will be the same thing as the base of the 1/2. Obviously, the right side is 2 to -1. That's a base. That's using 2 as a base. And the left side, we can do 2 to the power of 4 to the power of x. So it turns out to be 2 to the power of 4x. It's 2 to the power of -1. And like before, since this base is the same, since 2 is 2, therefore the exponent must be the same. And then we can set up a new equation now saying 4x equals -1. And then if you divide both sides by 4, so x equals -1/4. So the power I'm looking for is -1/4. Let's write it properly. the power is -1/4. It works because if I do 16, so we are done really, but let's check in. We're just checking it now. If I do 16 to the power of -1/4, it's same thing as 1 over 16 to the power of 1/4, which is the 4th root, 1 over the 4th root of 16, which is 1/2. So it works. That's just a check for it right there that it works. So the answer we're looking for is x equals -1/4. Here is another example in which this method really comes very handy. So if you're asked to find the log, okay, here's another example. Log base 6 of the 4th root of 36. Okay, so in this example, what we need to consider is that well, we can actually start off by writing it the way we did before. So we're going to ask the basic question. The basic question is 6 to what power? 6 to what power equals the 4th root of 36? Well, you know, we can actually rewrite the 36 as 6 squared. So 6 to what power equals the 4th root of 6 squared. And now we're going to apply the rational exponent rule, in which this 2 is the power and this 4 is the root. You know, if you remember what we did before with, if I have something like this, if I have the nth root of b to y is the same thing as b to the power of y over n. So it's the same idea here. So we're going to do 6 to the power of x is the same thing as 6 to the power of 2 over 4, or which is also 6 to the power of 1/2. So now that we have the same base, there's a base over here, 6, and the base is 6, so the exponent must be the same. So this x has to be 1/2. So here we have x equals 1/2. So it's really neat. We can check it by putting 1/2 on top of 6. We find is the square root of 6. Here is another example in which this also will apply. Let's say I have log base 1/8 is of 1/4. Okay, so this is like 2 fractions. So basically I'm asking, what power am I going to raise 1/8 to? Remember to use parentheses if it's fraction, to get 1/4. Now we cannot use base 4 for 8 because 4 cannot be raised to any power to get 8. So but we can use base 2 for 1/8 and base 2 for 1/4. So we write like this, basically 2 to the power of -3, that's 1/8 to the power of x, is 2 to the power of -2, because 1/4 is 2 to the power of -2. So now we can do 2 to the power of -3x equals 2 to the power of -2. And now since the base is the same, we can just say 3x, -3x equals -2. And dividing both sides by -3 will give us x equals 2/3. So we can continue to do more examples, but I think this should help you in setting up any exponent, any expression, so that you can be able to find the same base, be able to find a base that is common to each of them. All right, this is the end of the video.